Hello. Today I want to do a quick demonstration of something I built using Choria's Autonomous Agents. Autonomous agents are finite state machines hosted within the Choria daemon. As with all finite state machines, they describe all of the valid states that a particular service or abstract thing can go through, and then it can have certain events that can fire within that state machine that changes the state machine's current state into another state, if that event is valid within the state machine is in. Choria can host these things within it, and it can attach something called watchers to every state. So you can, for instance, say when a machine is in a particular state, let's say run, then it will health check. It will try to start something and continue to health check the thing that it just started. We use this for things like managing air conditioning, managing lights when we're away from home. You can integrate with various external things using any kind of exec. It can integrate with iPhones so that you can have a HomeKit button show up when a particular state is active, and really you can manage almost anything with it. Yeah, today I'm going to show a container that's being managed by this thing. This is a monitoring component for NATs, and yeah, it's running. If it dies, it will get restarted. It's health checked all of the time, and all the normal stuff that you would also be able to do just using pure Docker. I mean, a Docker can restart any file container. So why do this under via Choria? Because while these FSMs running, they're completely independent. They don't need any network connections or anything like that. However, you can um, um, interact with these state machines via the normal Choria RPC. So for instance, here we can see my machine is currently in the run state. In other words, the container is up and running. From here, I can enter an update state, a stop state, a maintenance state, or a restart state. Update will fetch a new version of the container. Stop will of course stop it. Maintenance will just tell Choria to just go hands off of this container. You're going to kill it. You're going to do whatever you want to do with it. Choria should not interfere. And what's interesting is, for instance, we can do if I were to transition this one to maintenance. Transition maintenance. Now that it is in maintenance state, we can see the available transitions have changed. I cannot go from maintenance straight to run or straight to restart or anything like that. The container is in maintenance mode. So the only thing you can do is to tell it resume normal operations, and the state machine will do its thing. This is really nice if you have many different kinds of machines all over the place, and you want to be able to orchestrate upgrades, downgrades, maintenance windows, these kinds of things based on standard Choria discovery. But in general, they just run. You can see down here we have a rolling events of the thing. So if I, for instance, transition to restart on this one, you'll see that it's gone to from run to restart. It's done a restart, and then from restart back to run. Run being the stable state where it settles when everything is healthy. If I kill it, it can take up to 30 seconds, or I think it's 30 seconds. Health check that container, and it will restart it. You'll see in a few seconds we should see some new surveyor-related lines coming here. So these state machines are, there we go. So it's checked. It checks is running. It failed. It transitioned to restart from where it was. and then it's back into running, and our normal health checks will continue. And if we do a docker ps, we can see it's running. So this is a small container management, really. It's capable of managing large fleets of containers across many machines, across many clusters. You can interact with them, you can schedule restarts, etc. Let's have a quick look at the what happens. How does this work? Well, the state machine, when it's in its run state, will simply run the script. And if the script passes, if it exits 0, we're all good. Then it is successfully running. While it's in run state and it will regularly health check the script, it will just make sure that the container is running. Of course, you can do a much deeper inspection into the container state than I'm doing. Yeah, I'm just being lazy. But the really nice thing is you can see these scripts are super, super simple. I'm just going Docker pull. That's it. That's my entire update step. If I transition this machine into update, all that's happening is a pull is being run. It's not restarted or anything like that. It's simply run update sh. And maybe you want to restart there. That will be up to you. So the really nice thing is that these small finite state machines, they can be really, really simple. Something really simple like just a couple of small shell scripts can very easily describe an entire container manager. Let's have a quick look at the machine definition. So we have our machine, it has a name. We want it to start in the running state. And we'll look a little bit about what that means soon. We want to support various transitions. So we want to have a transition, I can tell it, fire the maintenance event and move into a new state called maintenance. And we can fire the maintenance event from any of these namestates. So for instance, if I'm on maintenance, I cannot fire a maintenance event because I'm already in maintenance window at that point, for instance, just as an example. Resume, there's no point in trying to resume out of maintenance from within the run state. It wouldn't make sense. So I'm telling it only resume from maintenance. And so you saw earlier, while the machine was in maintenance state, the only valid transition was resume. And so we have a few other things here. Health checks can be done from a certain set of states. So we have a restart state, update state, and stop state. Now then, the watchers tells the machine what to execute while it's in a particular state. So here I'm doing an exec every 20 seconds. If ever this exec fails, exits non-zero, it should fire a restart event. And you can go up here, we can have a look, restart. We'll move it into the restart state, and we can do that from run or update. Okay. So this watcher, this check running, is only going to run during the run state, and so it's a valid transition for that state. It runs the check script, as you can see. There's no point in publishing a bunch of events every time the check is healthy. We only want to have events published when it's failed, and we give the script 60 seconds to run. There's more than it needs. And very similar stuff, restart, it's exec. If it fails, we will try every 15 seconds to restart the machine until it succeeds forever. It only tries to restart it when it's in that particular state. And when it is in that state, when it's successful, it will move on to a health check. And so similar, we can stop the thing, move to maintenance. We can pull and restart, and runs that. We can and finally, this is slightly different. I look if this file ever changes, which is the file that contains the definition and descriptions of how the container should be run. If that file ever changes, it moves into restart. So when Puppet or whatever you use to configure the state machine changes the definition and the arguments and parameters, maybe expose additional ports, it should restart the container. And that's it. There's less than 100 lines of YAML, and a couple of really basic shell scripts, is an entire container manager. It's remote addressable. It integrates with other systems. So, for instance, when I run Choria Machine Watch here, these are cloud events being published by the subsystem. So you can create monitoring tools. These events are sent across all of your infrastructure. The events and the states of the machines integrate with Prometheus, and all you had to do was write 40 lines of shell scripts in a small YAML file, and then let Choria run it. For the sake of just an example, the way I build these things in my environment is like this, for instance. I just go make a little bit of YAML that says run me this container, and it will figure it out and it will do its thing. So that's about it. That's a very small container manager written in an afternoon. And if I do something like this is a running NATS cluster, and I can do Choria request machine transition of the NATS container, and the transition we wish to do is a restart of the San Francisco cluster. Choria will do its thing and restart those 3 machines running in San Francisco. And this is a cluster with containers hosted San Francisco, New York, London, etc. And in generally is managed, is kept alive with Choria, but I can interact with it just when I need to, restart it just when I need to, and have a really nice network addressable container management system running across a cluster of machines. Yep, that's it. Hopefully a quick introduction to the kinds of things that we can do with Choria's autonomous agents, and I hope you enjoyed seeing that. Thank you.